So if you recall, to use the law of sines, the thing you need is any angle on the triangle, and you need to know the side length that's across from that given angle, okay? It's like that pairing, because whenever you use the law of sines, you're going to have like the sine of angle A over the side length A, where those are like a grouping, a pairing together that you need. So this first one, triangle A, do we have that angle and that side pairing given to us? I have 3 side lengths, but do I know any of those angle measures? None of them are given, but are there any symbols that like tell me what that angle is? Like, how about this right here? Oh, whoa. Let me get a drawing utensil. Do I know for a fact what that angle measure is? It looks like it could be 90, right? But is there anything that tells me it is 90? No. It could be 88 degrees, and it probably would still look the same. You know, I wouldn't necessarily see that difference. So we can't assume without that angle mark. So there's no other information given here. I don't know what any of those angles are. So because of that, we can't use the law of sines. So if we have a triangle where we're just given the 3 side lengths, we're out of luck. We can't figure it out. We need more information. I have to measure one of those angles somehow. All right, how about triangle B? Hey, I've got an angle. Awesome. And I have side lengths. So we can use the law of sines for that one, right? I'm seeing some head shakes. Why can't I use the law of sines? Right. I need that side that's across from it. Like I've got this angle here, which I need an angle, but I need the side across from it. Now, is there a way that I can figure that out, like subtracting from 180 or something? Or like, do I know what this side is? If that's 7 and 16, is there any way that I can figure out what that last side is? Does Pythagorean theorem work for this triangle? No, that's only for right triangles. So I can't figure it out. You know, there's no way to figure out this length, meaning I can't use the law of sines. It doesn't work in this situation because I don't have that angle side pairing that we need. So that's not good either. Kind of a bummer. How about that third one, triangle C? Does that have the info that we need in order to use the law of sines, that specific grouping of an angle and the side length across from it? Yeah, I've got the 43 and the 10. That's what we need. That's an angle and side pair. That would be like a single fraction that we'd use for one of our law of sines ratios. Boom. So that's what you would use the law of sines for if you see that in the diagram. But these other 2 situations, it's kind of a bummer that there's these other triangles that could exist in the world that we can't figure out their side lengths because they're not right triangles and they're not useful for the law of sines. Well, if only there were a way or some other law we could use, to figure out the sides and lengths of triangles in those first 2 situations, like A and B. Do you think there is such a way to figure that out? Anyone want to guess at what we're going to be doing in today's lesson? The law of cosines! Da, 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 da. Yeah, so there is a way to still figure this stuff out for this triangle A and this triangle B, and that's going to be using something called the law of cosines. Dun, 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 dun.
Wojcik?
Oh, I'm not sharing my screen, am I?
No.
That's awkward. Thanks for letting me know.
Yeah.
Before I got too far into the lesson. Gavin, where were you on that? Come on, man.
Hey, at least I told you.
And everyone else was just like listening to story time with Wojcik. All right, so law of cosines, 9.1b. So this is the other part of your first learning target in this unit. You'll have to use the law of sines and the law of cosines. Now, the law of cosines is a bit more involved. There are some more calculations than the law of sines. And so this isn't always going to be your go-to formula. This is kind of like your last resort. Almost like if you're solving a quadratic equation, it's super easy just to factor it right away, like x minus 3, x plus 2, and then flip the signs to solve it, as opposed to using the quadratic formula, right? Like you could use the quadratic formula for any quadratic equation, and you'll get the right answer. But it's much more involved, unnecessarily so. It takes more time than is needed. Same thing here at this law of cosines. You can use this on even right triangles if you want, but it's a lot easier to use like the Pythagorean theorem or sine or cosine or tangent if it's a right triangle, if it's set up. Now this then would be, if it's not a right triangle and you can use the law of sines, then you would default back to this law of cosines, all right? And so what you want to look for to use the law of cosines, it's one of those two situations that I had with those first two triangles, basically. And so I'll put it like this. You have either all three sides, right? If there's no angle given to you, then you can't use the law of sines because you need an angle. Or if it's the two sides and the included angle, what this word included means is that it's like in between, it's forming the two sides. So it's like I've got this side length, and that angle, like side A, side B, and angle C, if you will. If you have those in piece of information where you've got an angle, but you don't have the side across from the angle. So instead of worrying about these, basically, if law of sines doesn't work, we're going to use the law of cosines. Right? Always look for the law of sines combo first, that angle and side pairing, the angle with the side across from it first. If you don't see that, come in a little, because law of sines is easier. There's much less work with it. But if the law of sines does not work, that's how you know, all right, I need to use law of cosines for this problem. Because on your assessment for this target, law of sines and law of cosines are both part of one target. I'm going to give you a triangle, and you have to decide which law to use. Right? So you have to be like, oh, do I use law of cosines or law of sines? And hopefully you'll recognize, kind of like this warm-up, you'll be able to see if you try to use law of sines for triangle A, you'll be like, oh, it doesn't work. I can't use law of sines. Let's use law of cosines. That's all that's going to really entail. Whoa, that was quick. So I'm going to show you the law of cosines, and I don't want you to freak out because it does follow a pretty straightforward pattern, which of course I will walk you through to help you remember it very, very easily. This is one of those things where I'm not going to say you need to memorize it, but I'm not going to give it to you on the test. So this is something that you're going to want to know. You're going to want to be familiar with just through using it often enough, kind of like the quadratic formula. But I promise you, it looks scary at first, but I'm going to break it down very, very easily for you. Come on. I got your back. You a little nervous? All right, first thing, make sure that your triangle is set up just like it was for law of sines. As far as the labeling goes, you know how you've got the capital letters for the angles? And make sure you use the lowercase letter for each of those angle or each of the sides that are across from it. So like here's angle A, all the way across is side A. So it's the same like naming pattern that we use for the law of sines. And it doesn't have to be letters A, B, and C, right? These can be any letters you want. Just make sure you've got the capital letter for the angle and the lowercase for the side length that's across from that angle. That's the important part. So then if this is angle B, then all the way across from it must be side B. And then if this is angle C, all the way across that triangle needs to be side C with a lowercase c. All right, are you ready to see this? You a little nervous? You excited? No one's excited about math. I am. Okay, here's the law of cosines. Oh. A squared equals b squared plus c squared minus 2bc times the cosine of a. That seems like a lot, doesn't it? Holy macaroni. So yes, please write this down. And I am going to show you how to easily recall this. But having to sit there and memorize it, but you'll be able to recreate it. Because the thing is, there's no point in like trying to memorize it exactly this way necessarily, because this uses A, B, and C. What if I use, the letters M, L, and K or something on the triangle, right? Then this formula doesn't work. So it's kind of just getting familiar with how it's set up. And so here's how you want to think about this. Take a look at just this first piece right here. What's that look like to you? A squared equals B squared plus C squared. Isn't that pretty close to the Pythagorean theorem? It is the Pythagorean theorem. I just use different letters, right? A squared plus B squared equals C squared. Well, this says A squared equals B squared plus C squared. That's the Pythagorean theorem. It doesn't matter like which side I used for A. Like I could easily have used just side C, right? C squared equals A squared plus B squared. That is the Pythagorean theorem. You already know that. That's one of the first formulas ever learned in math. That's nothing new. So added on to that, take a look at this next piece in the middle. You're subtracting 2 times B and C. Those are the same two sides that are being added together in the Pythagorean theorem portion of it, okay? So minus 2 times those same two side lengths that you were just adding. Then the very last part, it is called the law of cosine, so believe it or not, we actually use a cosine in it. Now the cosine of which angle? There's only one angle in this entire formula, if you notice, right? Everything else is lowercase, those are all side lengths, except for one side, or for one letter. And whatever this angle is, this cosine A, it's always going to be the same as the one side length on the opposite, like that you started with. I think of them as like bookends, like whatever you start with, whichever letter you start with, you end with that same letter. So I started with side A squared, I'm going to end with the cosine of angle A. Now the thing with this is, we're not always going to be solving for that side A or that angle A. So we have to be familiar with this same formula and be able to apply it to any letters or any angle or any side that we're looking for. So let's just do the second line together. Another way that you could write the law of cosines would be, instead of starting with side A squared, well, what if I'm solving for side B? Well, let's think about what this would look like and trying to mirror that initial part of the law of cosines. We start off by doing a little mini Pythagorean theorem. If this is B squared equals, which other two sides do I need to be adding up? If this is the B, what are the other two sides? A and C. So I'm going to start by writing B squared equals A squared plus C squared. Right? So you've got one of each of the three sides. So you'd start off by writing B squared equals A squared plus C squared. The middle portion is minus 2 times which two sides? Well, it's the same two that we just wrote. I just did the A squared plus C squared, so I'm doing 2 times AC. 2 times A times C. The same two sides that we just added up. Last thing we're going to do is multiply this by the cosine of an angle. Well, which angle do we use? We'll look back at the very beginning of this. What letter did you start with? The B. So that means here we're going to take the cosine of angle B. All right, let's see if all of you can do the last one on your own. Write the law of cosines for C squared. Oh my gosh. Got that done before River did.
Yeah. Oh, did he? I'm pretty sure I'm done. Oh. Oh.
And you know, it looks right. Nice. Awesome. Yes, yeah. You figured it out. Awesome. Yeah, yeah. All right. It's not too crazy when you break it down a little bit. And we're going to practice this enough today that you're going to know this law by the end of class. All right, so don't think that you're going to have to sit there and work with flashcards to memorize it or whatever. And again, there's no point in memorizing one thing or memorizing all three of these because I might not even use the letters A, B, and C, and then this is pointless, right? It's more just looking at the relationship between them. That's why I explained it by breaking it up into those three different parts. You got the Pythagorean theorem portion minus 2 times those same two side lengths, and the cosine of whichever angle you started with at the beginning of the equation. All right. So c squared equals, well, my other two sides are a squared plus b squared. By the way, the order of those two doesn't matter because you're adding. It could be b squared plus a squared or a squared plus b squared. You get the same thing. Minus 2 times ab, because those are the same two sides that we just added up there. This is being multiplied by the cosine of, and look back at the very, very beginning, the first letter we wrote down on the other side of the equal sign, that was a side C. So this is going to be the cosine of angle C. So those are the those bookends that I talked about. And by the way, these, as I've been referring to them, the bookends, the A cosine A, B cosine B, C cosine C, that letter, whether it's the side or the angle of whichever you're solving for, is going to be one of those two bookends. If you're solving for the unknown side length, you're going to put it here on the left side. That's what you're solving for. If you're solving for a specific angle, you make sure that you put that angle here, because that is the only angle in this formula. So that's where you'd like set your variable for your unknown. And I've got a few practice examples for us. So we'll take a look at this together. Find the length of C given this information. So I didn't even give you a triangle. I'm just giving you those values just to see if, can you plug these in to the formula, and then can you calculate that with your calculator? So I'm giving you side A is 15, side B is 18, and that's a capital C, angle C is 34 degrees. So since my angle that I'm given is 34 degrees is C, I know that that's got to be one of my two bookends, right? That's the end of the law of cosines. You take the cosine of the angle. Since that's C, I know that the one formula that I'm going to use is this one, where I start off with the C squared. That same angle needs to start and end my law of cosines formula. So I'm going to use the C squared equals A squared plus B squared minus 2AB times the cosine of C. So we're just going to plug in those numbers right into this formula. C squared equals, because we're solving for side length C, A is 15, B is 18, so I've got 15 squared plus 18 squared minus 2 times those exact same two numbers, times 15 times 18, and this is all being multiplied times the cosine of that one angle of 34 degrees. If you notice everything I've got up there in blue, you can just type that all in at once into your calculator. Look at you square rooting. So just type that whole line right into your calculator all at once.
What's the squared button?
See this X with the square of it? So if I'm going to do 4 squared, I type 4 first and then press this, and it gives you that little exponent.
Okay.
And so that's 16. Any questions on calculators for any of these things? I'll bring up my own here. Carson, you figure it out? Oh, man. Slim, we're counting on you. X and the Y. There, x to the second power.
Oh, okay, I'm blind.
So if I wanted to do, so 8 squared.
Oh, no.
That's my fault. I'm sorry.
This guy. Did you? Oh, okay. All right, so I'm just going to type this whole thing in. 15 squared plus 18 squared minus 2 times 15. Instead of hitting multiplication, you can just use parentheses because that implies multiplication. We've got something in parentheses right next to something else. Parentheses 18 times the cosine of 34. This is degrees, so before I hit enter, I'm going to hit the mode button and just make sure that I am in degree mode right here, which I am. Second quit gets me back to the screen. There's my calculation. I hit enter, and I got 101, which is a pretty big number. Especially when I look at the other two side lanes, are 15 and 18. Then all of a sudden, I get this number of like 101. That's an 8, Wojcik. Come on, you're better than this. There's that a 1. Well, why is that number so much bigger than the 15 and 18, everybody? Yeah, that's not side C. This is C squared. I'm not solving for C squared. I'm solving for C. So what's my last step? Square root. Square rooting. So I can hit second square root, puts the square root symbol. By the way, everybody, on these graphing calculators, if you ever want a nice little shortcut, whereas, you know, if I type in 101, it won't be like as close of an answer. It's rounding off a little bit. So you could do a few decimals. Like you could type 101.31 or 3197 or so forth. The more decimals you use, the more accurate your answer will be. But instead of typing in every single little number, here's a really cool shortcut with these calculators. If you just press second, and then down at the bottom, that little negative sign in blue, it's got ANS, and you hit that. That stands for answer. And what that does is that automatically types in whatever your previous answer was, exactly. So by doing this, it's giving me this whole number and even like more decimals that it doesn't even show me. So this is like the most accurate way you can get an answer without worrying about like rounding too early in your problem. So remember with the law of sines on Wednesday, some of you got slightly different answers than what I had because you rounded like 1 or 2 steps earlier with like your sine of an angle, or you took off too many decimal points. And so by doing this, you're going to get a more precise answer. Whereas if I did just square root of 101, you can see these numbers, they're pretty close for the most part, you know, but if I said round to the nearest hundredth, we would have different answers, very slightly different, but for the most part, we see it's 10 even the nearest tenth, this would be 10.1, that would be 10.0. So you do want to try to keep as much information as possible during all your calculations until the very, very last step. So as this is my final step, now I would round it and say like, oh, 10.05, for example. So square root, those cancel. C is approximately 10.05. So that's the length of C. And also just to reassure you, on a test, I don't grade for like rounding errors. You know, I'm teaching you, can you use the law of cosines? You did everything else, but then you put 10.06. Clearly you understand the law of cosines to get to that point. If I had a learning target for rounding though, that'd be a little iffy. Questions on using this law of cosines? It's a pretty straightforward formula once you plug everything in. All right, let's solve this entire triangle. Ooh, got to find all the angles. Where do we even start though, Aiden? I mean, like what? I know. Let's start by drawing the triangle in our notebook. All right, so the first thing we want to use, first off, if it were a right triangle, that'd be awesome. I could just use SOHCAHTOA, but it's not a right triangle. Even though it might look like it, I don't have that information. All right, so then law of sines would be the next easiest thing to use, but I don't have that angle side pairing, so I can't use law of sines. I need to use law of cosines. Let's start by labeling the sides with A, B, and C. It doesn't really matter which one's which. I'm going to just make A up at the top, B down in the lower left, and then C in the lower right. And now we're also going to want to label each of the sides appropriately as well, because we need to know sides A, B, and C and angles A, B, and C in order to use the law of cosines correctly. So across from A, this would be side A is 31. The 48 is side B, and the 29 is side C. Now I've already got 3 side lengths, right? To solve the triangle, I need all 3 side lengths, but I also need all 3 angles, and I don't have any of them. We need to start just by finding any one of those angles. Now the cool thing is we can find any of those first. It doesn't matter which one. So what do you want to solve for first, everybody? Angle A, B, or C? Thank you so much. I know that this early morning class is tough to think, but when I asked you to name a letter, A, B, or C, I figured most of you could handle that. So nice job. Guy doesn't need to do his backflips today. He's good to go. Let's solve for angle A first. So because we're solving for angle A, that's also going to be the side length that I start with in my law of cosines, right? The one angle you use, that's also the side that starts on the left side of the equal sign. So I'm going to start by writing a lowercase a squared equals. Then we're going to write out the rest of the formula from here. And remember, we do a little Pythagorean theorem type of a thing. We square the other 2 sides and we add them up. So b squared plus c squared. We then subtract 2 times those same 2 side lengths that we just used, B and C. And then finally, in the law of cosines, we use the cosine of that same angle that I started the whole problem with was side A. So this is going to be the cosine of angle A. So first, I always suggest write out the formula that you're going to be using. And now just plug in all the values that you know. And you'll have only one variable. You'll have only one unknown. That's going to be this angle A that I actually wrote in blue to make it stand out. But everything else we actually have a number for. So let's just plug in those numbers. So A squared, side A is 31. B squared, B is 48. Plus C squared, C is 29, so plus 29 squared, minus 2 times those same 2 side lengths that we just used, that 48 and that 29. And then all of this is being multiplied by the cosine of angle A. And I don't know what angle A is. That's what we're going to be solving for. Just to give you a little preview of what's to come, since we're solving for an unknown angle, we will have to use the cosine inverse on this. Just like with law of sines, when we had to solve for an angle, the last step was to use the sine inverse. Same thing here. At this point, we have a pretty straightforward algebra equation. And what I want you to do is think about this last little piece here at the end, this cosine of A. we need to get that all by itself on one side of the equal sign, meaning I have to cancel all the other pieces off of that right side of the equal sign. So what do we have? I've got to get rid of basically three things. I've got to cancel out, one is this 48 squared. Second thing I have to cancel out would be this 29 squared. And then the third thing I have to cancel out is basically this entire grouping, this coefficient of the cosine of A. So we've got to get rid of all three of those numbers. And they are all just numbers. So if you want to make this a little bit easier for you, we could just, multiply each of those things out, right? You're just squaring numbers. Let's go ahead and do that. So first off, on the left side, I'm going to need more room. I've got 31 squared, which is 961, equals 48 squared, which is 2,304, plus 29 squared. 29 squared is 841. Minus 2. Oh, I can actually multiply that. 2 times 48 times 29 gives me 2,784. And remember that this is all being multiplied then by the cosine, of angle A. I'll write that a little bit better. And that cosine of A is one we wanted to get by itself. So at this point, you're just going to cancel stuff out, nice and easy. This 2,304, how do I cancel that out? We subtract, yeah. So let's subtract that from both sides, right? Minus 2,304 from both sides. Minus 2,304. Those are gone. How do I cancel out this 841, everybody? You can say it. You know how. Yes! Awesome! Subtraction again. Exactly. Minus 841. Minus 841. Those cancel out. So let's see what our equation simplifies to at this point. We had 961 minus 2,304 minus 841. And our left side now is going to be negative 2,184. And that equals, on the right side, the last thing we have is this negative 2,784 times the cosine of angle A. Everyone with me so far to this point? Can I get a quick nod if you're following these steps at least? Okay. Remember that we need to get the cosine of A all by itself on one side, but there's this negative 2,784 in front of it. Now's where you have to be careful. How do I cancel out negative 2,784? We divide. All right. A lot of students are going to want to add it because you see that negative sign and you just got rid of two other numbers by just subtracting. But this here is being multiplied by the cosine of A. It's like if I have 3 times x, or I have a 3x, to get rid of that 3, you have to divide by the 3. So what we need to do from this point to get rid of that last term is division. I need to divide by negative 2,784. Negative 2,784. So that these both cancel out. Divide by negative 2,784. And we get a decimal. 0.784. 448. Remember, in the middle of the problem, I'd suggest keeping more decimals than you think is necessary. Go like 5 or 6 of them. And don't round off until like the very last step. And so this equals the cosine of A. So we finally got the cosine of A all by itself on one side. But remember, the last thing we need to do is find A itself. So what do I need to use at this point, everybody? Thank you. Yes, the cosine inverse. Solve for an unknown angle, use the inverse. So I'm going to say the cosine inverse of this decimal of 0.78448 will equal angle A. So second cosine inverse. On your calculator, you can just hit second answer, and it will use the whole decimal already for you. And I got angle A is approximately 38.3. Anyone else get something close to that? Close to 38.3? All right, so law of cosines. It's a lot of work when you're solving for an angle, a lot of steps, but they're not difficult steps. We subtracted, we divided, we squared some things. Those are all very basic steps. There's just a lot of them in a row. Not a difficult problem. So that's angle A. Going back to here. So that was 38.3 degrees. Awesome, that was one angle. We need 2 more. So let's do that whole process 2 more times. Wait a minute. I don't have to use the law of cosines anymore for this problem. Now that I've got one angle, what can we use instead that's a little bit easier? Yes. Excellent. I now have an angle. And check it out. I've got the side across from the angle. We can use the law of sines now for this next one. That's a lot easier. Right? It's fewer steps. So I can just set up my little ratio, said, hey, the sine of 38.3 over 31, that's my A fraction, equals, and then pick another side, B or C, it doesn't matter. I'll just use B because it's the next letter. Sine of angle B, which I don't know, but side B is 48. So we can solve this pretty easily. That's just that cross multiplication. So I'm going to take the sine of 38.3 times 48 divided by 31. And I get the sine of B equals 0.95965 blah, blah, blah. Last step to get B is to take the sine inverse. So B is approximately, second sine inverse, second answer. Anybody get 73.7? I saw a couple nods. So that's just a refresher from last class. So angle B right here is 73.7 degrees. Now we have one angle left, angle C. I could use the law of cosines if I wanted to, and I could get the answer, but that's a lot of steps. I could also use the law of sine, just like here, which is quite a bit easier. There's actually a third way I could find angle C, and that's the easiest. What's the best way to get angle C at this point?
Add the other 2 angles together.
Yeah, exactly. Right? We know that all 3 angles have to add up to 180. So let's just take 180 and subtract the sum of those other 2 angles. So I'm going to take 180 minus angle A, which was the 38.3, minus angle B, which was 73.7. And when we type that out, we get, let's see, 38.3 minus 73.7, 68. That works out kind of nice. And angle C then is 68 degrees. We have all three side lengths, and now we have all three angles. Da, 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 da. Just crazy to think of. You can be given any three random side lengths of a triangle, and you can find all the angles now. Look how powerful this math is. Can't wait till some of you become like city planners or engineers. And you're going to have to use this stuff. Questions on any of those steps? And mind you, I hope you do realize that this was long. There were a lot of steps, but each step individually was pretty basic, pretty straightforward, pretty simple, basic algebra. Just a lot of basic algebra steps. Was everybody able to get all those values themselves also on their own using their calculator or whatever, or figuring out what we did in each of those steps before we move on? Okay. One more for you. Solve the triangle. This one's going to be easier, don't worry. Let's go ahead and draw the triangle. Label the angles, ABC. Let's see what you can do. Nice. That 47 is the angle, not the side length.
Oh, shoot, yeah.
I would have got a weird answer. Yeah, nice. Good job. Plug them all in. So this last thing, cosine of A. We know angle A, don't we? Look at your triangle. What's the measure of angle A? Yeah, so you can just type that whole thing in. Remember, you should only have to use law of cosines one time Once you get that first angle, you can then just use law of sines for that other angle. And then just subtract those two from 180 for the third angle. It gets easier with each angle you solve. So that 47 isn't a side length. That would be our variable, A. Because remember, the way that law of sines works, the left side, this little a squared, that's this number. I don't know what that value is. That's what we're solving for. The 47 is the angle. That goes at the far end, cosine of 47. Use 47 for both of those, for little a and for big A. Did you see that? So from what I saw, most of you had this first line written correctly. A squared equals, then the rest of it you had values. Make sure you're using that 47. That's an angle. So that should be for the capital A, not for the lowercase a. That's what we're solving for. You just plug all of that right in to your calculator. 22 squared plus 27 squared minus 2 times 22 times 27 times the cosine of 47. Enter. I get like 402.7859. Last step, second square root, second answer. And I got A to be approximately 20.07. Anybody else get that for A? Right around 20? Nice. Good work. Very good work. You probably rounded earlier, or fewer decimal places right there. Silly goose. It does happen. That's all right. So you got one side. Now we have all three sides. I just need two more angles, B and C. And at this point, though, we could just use like the law of sine. Because my first fraction, I can do the sine of 47 over 20.07. All right, because I have that angle side pairing, angle A and side A. And let's just do B next, or we can do C. We did B last time. Sine of angle C divided by side C, which is 27. Cross multiply. Sine of 47 times 27 divided by 20.07. I got the sine of C equals 0.98388. Second sine inverse, second answer. And angle C, I got approximately 79.7 degrees. Anybody else for C? 79.7 degrees. Very cool. Now at this point, I've got two angles. To get the third angle, don't use a law of cosines. Don't use a law of sines. Just subtract from 180. 180 minus 47 minus 79.7 and 53.3. Anybody? 53? 53.3 degrees. Yeah, we're good?
Let's run out B.
Yeah.
Was that minus right? And then cross multiply.
So what did you get?
Yep.
And then I got that or whatever. And that equals.
This isn't a...
Yeah, got the wrong answer.
So you
Oh yeah, you
I'm
just
doing-
labeled
I'm doing
differently.
B.
Yep, that's fine.
And then I got that.
Then take the
we'll
sine
move on.
inverse, because if sine of b is this, you want to get rid of
Oh,
sine by
okay,
doing
so-
that negative 1.
So like you're kind of subtracting it.
You're
You know,
It's not really subtracted. It's
yeah.
like you're taking the sine inverse of both sides. You know how like you take the square root of both sides to cancel out a square? You take the sine inverse of both sides to cancel out a sine.
So then I type it in. And then...
Yeah, the sine inverse of that decimal.
Okay.
Yep. Yeah, type the decimal first.
I just do these.
Yep. Yeah, you labeled it the other way. That's fine. And second sine.
Is it times?
Nope.
Or just
Second sine inverse. It's at 53.5. So I gotta look at my angle B. 53.3. You're there.
all right.
You got it. You're good?
Or 81.7, my bad.
Anyone else having any issues with any of those three pieces before we move on?
I did not get the right answers. This is what I did.
All right, making sure you're in degree mode first. So 22 times 47. Oh, you did the cosine inverse. But
Oh, sine.
we're using the sine now at this point. So do the sine inverse of like 0.80448. That's all. It's tricky because we're using law of cosines first, but now we switch to the law of sines.
Now I got it.
Nice job.
So I got basically there, but I forget what you do.
So type in the decimal first
Okay.
on that calculator. And then to get rid of the sine, you do the sine inverse. So press second sine. And that does that sine with like the little negative 1. And so 79.6, like I had 79 point. So yeah, you got the same thing.
Okay.
That's it. Anybody else questions on like using the calculator to get any of these values? We're okay over here? We're good? Anyone at home? Anybody have any questions on how I got these calculations, or do you want to see it on my graphing calculator or anything like that? Or are you doing okay? Okay. Well, that's it for today. Dun, 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 dun. Look, next slide, it's blank. There's nothing else. 35 minutes. Actually, 35 minutes and 45 seconds. What do you want to do? Watch a movie. How about we practice the law of cosines some more? You want to watch Shrek, because he's got layers, right? Don't tempt me. All right, so 1, 2, 3, 4. It's good. We're going to work on these. Everyone at home, this is all just online. Go to my P-Learning page. Go to my calendar. Algebra 2. Calendar. And then click on today's law of cosines. Let me go to the student view. There we go. Law of cosines. And here you go. You've got your practice right there for you. Open up in a PDF for you. So that's what we're going to be working on. And then I do also have the answers right here for you to work on. So best of luck, everybody. Shout out any questions.